This picture of a crab. And I want you to take a real good look at this crab, especially the size. And later on in the presentation, I'm going to tell you why this is important. So I guess I'll start with Mel. Okay. All right. So, like Mel said, I am part of the science team, and we're the guys that go out on the boat and try to figure out how many crabs we're going to have each year. There we go. So, why are blue crabs important? Ecologically, blue crabs are important both as a predator and a prey. And in the Chesapeake Bay, adult blue crabs are a major predator of bivalves, such as clams and oysters. In fact, it's really interesting to watch a blue crab open a large clam. So what they do is they take their claws and they wedge it between the two shells, and they'll just wait there. And then when the clam opens a little, it'll push its claws into the shell and kind of ratchet it open. They're also a major predator for juvenile crabs. They're cannibalistic. And of course, juveniles feed on smaller things such as small crustaceans, worms, and plants. So really, what blue crabs eat are stuff at the bottom. Now, what eats blue crabs other than us? And the short answer is fish, which mostly live in the water column. Now, another way to think about that is that the blue crab serves as a link of energy between the benthos, the bottom, up into the water column. So, the next time you're eating your crab cake sandwich, you can thank the blue crabs for that fish sandwich you might eat tomorrow. And I'm going to apologize for this picture because it's kind of making me hungry. So, yeah, I'm sorry for anyone that's getting a little hungry. And I think that we can all agree that it's in everyone's best interest to make sure that the crab population is healthy. So, I'd like to go over just a little bit of history. So, even before we had recorded history, people have eaten blue crabs along the Chesapeake Bay. In fact, there was a paper just last year from the Smithsonian, and they found blue crab shells in Native American midden or trash piles dating back 3,000 years. Now, what's really interesting is these crabs were 10 inches long, not including their claws or legs. So that picture that I'm passing around, that's that blue crab. That's how big it was. And it's pretty intimidating. I don't think I'd want to pick that up. So, during the colonial period, we still have records that blue crabs were fished, but they were fished and eaten locally because there really wasn't a good way to store the meat, nor really a fast way to transport it. But this all changed in 1963, and that's the first recorded shipment of soft-shell crabs from Crisfield, Maryland, to Philadelphia, Pennsylvania. In 1870, there were two main ways to catch crabs. There was the trot line, which y'all have already heard about. It's basically a line with baited hooks. And then there's the crab scrape. And basically a crab scrape, you pull it along the bottom of the seagrass and you can catch soft-shell crabs. Now, by the 1900s, crab dredging was born. And it was actually born out of clam dredging. So someone came along and they had their clam dredge and they were dredging around and they found out during the winter that they could catch blue crabs. And they're like, this is a great idea. During the winter we can just do this and we can catch blue crabs. So that industry started in the 1900s. By 1928 we had developed the crab pot. Now, the nice thing about the crab pot was, in a way, it was a lot less intense, right? You don't have to pull a boat to start collecting crabs. You can just kind of set them out there, let them sit, baited with fish, and the crabs would start coming in. And this started making its heyday in the 1950s. That's really when the crab potting really took hold in the Chesapeake Bay. And just a side note, It was 2008 when the Dredge fishery was closed, and we can talk more about that later. By the 1970s, this was a great time because technology actually allowed us to keep crabs until they molted in what's called shedding tanks, and this is really why we can enjoy soft-shell crabs now. Okay, so I'm going to talk very, very briefly about their distribution because, as you already know, the blue crab spans all the way from Nova Scotia, Canada, to the top of Argentina. And evidence suggests that the genus evolved actually in the coastal ocean of the American tropics. So, while adults span this wide range of temperature and salinity, the larval stages, so the babies, they're bound to these ancestral tolerances, and they have to develop in saltier, warmer waters, which is why the female crabs go to the bottom of the bay to release their eggs. So now that we know where they are and sort of what they do, I'm going to talk a little bit. There's Chesapeake Bay. We all know where that is. And if you want to come to Marine Science Day, that's where Gloucester Point is. That red dot right there. I want you to remember that.
That's May 21st, right?
Yes, May 21st. All right, that red dot, that's where VIMS is, and this is the lower Chesapeake Bay. So, blue crab spatial distribution is wide, but it differs whether you're male or female and how big you are. So this is sort of the orientation slide. We have the rivers, we have VIMS. There we go. And the color of the land is going to change with the seasons. So right now we're in winter, that's the gray. And then we're going to go into spring, which is a light green, summer the dark green, and fall, which is that dark brown. These blue pathways are just the channels. And these are the crabs we're going to be looking at. So everything on the left is what you could consider, you know, a baby crab, a larval crab, just the different stages. The stuff on the right, those are the adult crabs, and that right there in the middle is a pre-molt female, right before her terminal molt. So she hasn't met the blue crab of her dreams yet. All right, so, you know, to make this easy, we're just going to look at one male and one female. So we'll just name them Adam and Eve, make it real easy. So in the winter, when the bottom water reaches about 10 degrees Celsius, crabs are buried in the sediment. And this is usually when we take our points, because it's easy, they're not moving. Males usually tend to be in the tributaries, and females are close to the main stem. Now, for those of you that have never seen a crab bury, this isn't a blue crab, but it's a swimmer crab. And it's really neat. They'll actually use their back fins and sort of bury them in. And watch real close. You might miss it. There it goes. And come on, you can do it. Oh! And she's gone. So, you can see why we would use a dredge to dig them up, because dredges have the teeth and they're actually able to dig into the sediment to pick up these buried hibernating crabs.
If only the water was that clear here.
Yes, and that's one of the reasons why we don't have a picture of a blue crab doing this. Though the water was really clear last year, if y'all remember. I don't know. Clearer. I could actually see about 10 feet down, which was nice. So you usually can't see your hand. So, spring comes, and the water's warm, and adult females already at the mouth of the bay will spawn. It takes them about 2 months to develop their eggs. So spawning occurs in late spring or summer, and we'll just follow this cohort through the late spring. So blue crab larvae are released into the entrance of the bay, and then they're transported in the offshore waters above the continental shelf, and they'll develop in the coastal ocean for about 2 months, and they'll go through 7 or 8 stages. Now, one female crab produces, on average, 3.2 million larvae every time she spawns in the Chesapeake Bay. And they spawn about 3 times a year. So, in the summer, our female may, release another batch of eggs. Males may wait for another female to give sperm to, but otherwise, adults spend their time foraging on the bottom of the bay in the tributaries. So there they are foraging, really fast. Now by fall, these zoea are the first batch. They metamorphose into the megalopal stage, so now they look even funnier. And they're transported back to the mouth of the estuary, where they'll use selective tidal stream transport. So what that means is, basically these little guys are really good at moving up and down. And they're also really good at figuring out what the current is. So when they want to go with the current, they move up, and the current takes them into the rivers. When they want to stop, they move down to the bottom. So, there they are. Here they are going. Some of them move further upstream. Now, we believe they selectively choose to settle in seagrass beds because they offer protection. There aren't a lot of predators there. They've got a lot of cover, which is why seagrass beds, at least for the blue crab, are important.
Ma'am, in this stage, how big a creature is this?
Oh, this megalopy is about this big.
Okay.
It's really tiny.
So this isn't the scale.
This is definitely not to scale. If this were to scale, I think that we'd have to call the Navy. And I certainly wouldn't have my job. Be a little too dangerous.
Do you have any clue of what the driving force is? Is it salinity or genetics or GPS or magnetics or
So
for them to be moving in that direction?
So we don't know exactly, but we do know that they can sense out the salinity, right? So fresher waters from the rivers. We're not exactly sure how they get to seagrass beds. A lot of people think that they actually are able to smell the seagrass beds using chemicals. But that's something that we're kind of not sure about, and it's really hard to get money for people to study stuff like that. Like it's very interesting. There are a lot of things that are interesting that we just don't know about the blue crab because there just hasn't been any
So
money.
it's pretty much a mystery why they go from a seagrass bed at Cape Charles all the way up to Maryland. Right? That's a mystery, right?
Well, actually, if you could reserve that question for later, Gina Ralph here is actually our resident juvenile blue crab expert, and she might actually know more about that than I do.
Okay. Yeah, so that's the question. Why would they go all the way up to Maryland?
I know. Maybe we should just build a wall, and then they'll all stay here, and maybe we'll have Maryland pay for the wall.
That's when you go to Maryland.
Trump with it.
And then we won't have to worry.
And the crabs will
Or John.
Get Maryland to pay for it.
So once Maryland pays for that wall, we won't have to worry about the top part of this figure, and we'll be able to keep all of the male crabs. So anyway, once they've settled where they're going to settle, and they actually start to look like a blue crab, just a really small blue crab. Now winter comes. The water reaches below 10 degrees again, the crabs bury, and there we are, taking our samples. Spring comes, and this time I want you to focus on the juvenile crabs. And they'll continue to grow and molt, and when they reach the right size, which is about 4 inches, they're ready to mature. There we go. So, April and May mark the peeler run. And this is when the juvenile females have gotten big enough to complete their terminal molt. Usually male crabs wait near the mouths of the river to mate with a female that's ready. And for the female, this will be the only time in her life when she'll actually be able to mate. And she'll keep that sperm in a special sac. It's called a spermatheca. And she'll use the packets for the rest of her life. She'll actually take the packets and impregnate herself every time she wants to have a brood. And if we move down, for example, to North Carolina, Florida, where the waters are warmer, they'll actually molt more than the crabs in the Chesapeake Bay, because we have this stop period, right, in the winter when they bury. So there they are, and she's found the male of her dreams, and now she will never molt again. So if she loses an arm, she's lost that arm for life. So in the fall, females will start to migrate until they reach the mouth of the bay, so that in spring, after the winter chill, they'll all be ready to spawn. So we know in general that during the winter, females are here in this pink block, and males and juveniles are pretty much in the rest of the bay, and of course smaller juveniles are more in the lower bay because they haven't quite made their way up to Maryland. Now, if we were to have a cold snap year, now if it just got cold real fast and they didn't have time to migrate, our map would probably look something more like this, where the females were kind of on their way, but then all of a sudden it got cold and they had to bury down. And usually these are the winters where there's a lot of female mortality because they're up in Maryland and it's just too cold for them. So, crabs are important. And I'm going to tell you a little bit about the Winter Dredge Survey. So, the original goals were to estimate how many crabs there were, the size and the sex of them, and it's also a way for us to estimate sort of the exploitation or the fishing mortality. So to do that, there we go. To do that, we take 1,500 random stations, and they're split up into these three strata. The females at the very bottom, that super dark red, that's usually where you'll find a lot of females. The green is where you'll find a lot of juveniles and males. And that blue part is where you'll find pretty much everyone, and it just depends on the winter. There we go. All right, so I'm going to take you through a tow. So now you guys can feel like you're on the dredge boat too. So before a tow begins, we take some measurements. We look at the temperature, we look at the salinity, and we look at the dissolved oxygen. And the boat can only go in areas deeper than 1.5 meters, otherwise we'll get stuck and no one wants that. The tow is about 2 meters wide, and the liner has a stretch length of 1.3 centimeters. So we tow this for about a minute at 3 knots. And what you're seeing here is actually a scallop dredge, because when we've tried to do this, you would only see black because it's so murky down there. But it gives you an idea of what a dredge actually looks like when it's going through. It's digging. And you can see all of that shell material just go into the bag. The nice part about dredging is you can continue to tow this bag until all of the mud and sediment has popped out. So there goes the dredge boat. We have our starting and ending coordinates, so we know exactly how far we've gone. Usually we go about 100 meters. It's plus or minus about 25 meters. That way when we get the crabs, we know how long we've gone, so we can make our estimate a little better. So we take the crabs, we measure them, we see if they're male or female. We take a note of whether it's sandy, muddy, oyster shell, clam shells. We also take a look at bycatch, most notably horseshoe crabs. Horseshoe crabs get pretty messed up in a dredge, actually. Sometimes you'll cut them in half, which is sad and tough. But there is a limited fishery on horseshoe crabs. So any crabs that we we kill have to go into the numbers for next year to VMRC to tell them, oh, okay, the dredge fishery took out 2 crabs, so we have to subtract that. Our dredge. So when we're finished actually measuring the crabs, we'll take any healthy looking female and we attach a bright orange tag. And if you find one of these crabs with a tag on it, it's worth $20. So these crabs have an ID and a phone number, and the blue crab tagging program is one of the ways that we know an adult crab is about 3 years old. And it's also the way we think that the maximum age right now for a crab is somewhere around 8 years old. All right, so on to the meat. The next few graphs are the dredge survey data for the last 26 years. This graph basically shows you our estimate of the total abundance of blue crabs in the Chesapeake Bay. And just this week, this year's results were released. That's that last point right there at 2016. And I just want to overlay the commercial fishing data. And what you'll see is that the trends, for the most part, look similar. So if we think that there's a good year, the fishermen found it to be a pretty good year. Except for 2012, and I'll get to that in a minute. And just the other day, I was talking to a couple of commercial fishermen, and they were calling us with tag numbers because they wanted to get their $20, and they were telling me that they were catching half a bushel a pot right now. So for anyone that doesn't crab, that is a lot of crabs. They're catching their limit daily with very little effort. Now remember that 2012? You see that big spike at 2012? That's actually the abundance of the juvenile blue crabs. So these are under 60 millimeters. These are not legal size crabs. Hence why when we go back here, 2012 looks so weird. It doesn't quite follow that same pattern. But for this year, juveniles have been on average, actually, if you take these 26 years and you average them out, it's around the average amount of juvenile blue crabs. So that's pretty good. Now this is the last graph I want to show. And it basically shows you the guidelines for management, which are based on maximum sustainable yield theory. And there's a lot of fancy math behind that red and that green line. And you can see the red line's at the bottom, the green line is at the top. And basically what you need to know is if that we're under the red line, we're in trouble. And if we're around that green line, the population's doing well. We just have to make sure that we don't overfish the crabs. So, you may also be wondering why the rules are for female crabs, and it's pretty simple. Because of the life history, one male crab can transfer sperm to many females in a season. And those females are set for life. The next year, he'll transfer more sperm to more females, and they're set for life. So, it's more important for us to have hard rules set for the female population. That being said, there's actually a trigger for male harvest too. So if we're harvesting more than 33% of males, management is discussed for males. So it's not like we're trying to fish out all of the males, but we're more worried about the females because they're the ones with the eggs. And just in case you were wondering where the crabs were this year, the short answer is pretty much everywhere. The map on the left shows the juvenile abundance, so these are those baby crabs, and you can see that they're pretty much near the mouths of those rivers, and that's generally where we find a lot of seagrass. And the picture on the right, that's where the adult crabs are. Remember, close to that bottom, that's pretty much female crabs right there. And that also covers quite a bit of the female sanctuary. But yeah, they were found pretty much everywhere, even up in Pocomoke, up on the eastern shore.
I was up in the Rappahannock last week. I'd never seen so many pots out.
Oh yeah, you know, yesterday went out on an oyster boat, and I was looking as I was going past the James River, and as far as I could see, there were pots just everywhere.
I have a question about the sanctuary.
Uh-huh.
You said, if I'm recalling your words correctly, if you could go back to that one,
Yeah.
that where we see
The female
the
crabs.
female crabs is also pretty much the sanctuary,
Yes, it's
which
pretty much
means
the
that
sanctuary.
can't be, they can't harvest any crabs out
They
of that.
can't harvest any crabs out of there during certain parts of the year.
Ah, okay.
So it's not closed forever. It's just closed during the times that we think that those females will spawn. So the crab fishery, before it
Do you have
opens,
a
it'll give them
slide
a
of the
chance.
sanctuaries?
I don't have a slide of
If
where
you
the
go to
sanctuary is.
VMRC's website, you can see a chart of the sanctuaries. They have them on their website.
Yeah.
Okay.
So it's just to give them a little bit of a chance to spawn if they are ready to spawn. They're already down there.
You built the wall into these pictures.
I did. I did.
Does that imply, do people sample north of that wall?
Yeah, so actually we're only responsible for the 750 points in Virginia.
Okay.
And Maryland DNR actually takes the other 750 points in Maryland. And when we're done with the survey, we actually send the data up to them. They process it, and then they're the ones that come out with the numbers that I just showed you.
Do you work at all with the Smithsonian Institute up there off the Road River?
Not for the Dredge survey, but we have had collaborations with Tuck Hines and his lab. I can't remember the last time we've done something with them. But we do collect a lot of specimens too for the Smithsonian.
That's not a bad place if you're up in that area to go and stop in and see them. They're got a place to see them. They do a lot of things with kids and that kind of thing. It's a smaller facility than you guys have,
Yeah,
but it's not
yeah.
bad.
Cirque is really nice. They did do a lot of little tagging programs with microwire and juveniles, which is kind of crazy because juvenile sometimes is like this big, and you're sticking in a little microwire that has a number on it. You're sticking it in them, letting them go, and then trying to catch them back again. And you have a little wand that tells you whether there's a piece of metal in there. If there's a piece of metal in there, you take it out, and then you put it under a microscope, and you try to read the number. Yes.
How does red tide affect the crabs, if anyone?
Red tide. Well, red tide, I believe, isn't a big factor for blue crabs only because they can move and they have a really great sense of smell. What affects blue crabs more is hypoxic areas. So those are just dead zones in the bay where there isn't much oxygen. Now they can move out of those too. But from what I've read, that those are more of an issue for them than the red tide.
The red tide and the dead zones affect the fish more than the crabs.
I don't know, mainly because I don't really know how they affect fish.
Okay.
So as I can't make that comparison. Just real quick, I wanted to acknowledge everyone that's part of the Blue Crab Survey. For anyone that couldn't see, those are those bright orange tags, and we stick them on the spines, around the spines of the females, adult females, because they're not going to molt anymore, so we don't have to worry about them losing the tags. And I promised I would show this. So that thing that's going around, if you put your email address on there, you'll get our monthly newsletter. And you should come visit us at Marine Science Day, May 24th. I will be there with a lot of crabs if you would like to play with them. And with that, are there any questions?
So, the migration question from before?
Oh, migration question.
So, it's my understanding that the blue crab has evolved to utilize the entire salinity spectrum. So the babies are really tied to the high salinity areas for the development of the megalopal and the zoeal stages. But as they grow, they actually get more of a benefit from using low salinity areas. So So they migrate from the seagrass beds at the mouth of the Chesapeake Bay, where they're protected from predation because they're small in these seagrass beds. But as they get bigger, they don't have that refuge from predation anymore because predators can see them between the seagrass blades. Whereas when they're 2.5, 5, 10 centimeters, very, very small, they can hide within the blades and they aren't really preyed upon. So then they move out of the seagrass beds at about somewhere between 15 and 20 millimeters is what they currently say. So about this big, they'll migrate out of the seagrass beds to lower salinity areas where there's a lot of food and fewer predators.
One more question.
Uh-huh.
At VIMS, you work with crabs, oysters, many fish species
Yeah.
with data in the bay. Has anybody ever done, or that you know of, doing work at a metadata level, trying to look at the health of 10, 12 species of things? And is there a correlation, do we see where crabs are doing well, rockfish are doing well, and then on, right? If you look at...
Yeah. So there have been some efforts to do what's called ecosystem-based fisheries management. And basically you're taking all of the species that are fish that you have data for, and you're trying to sort of conglomerate that into one model. And the main issue that's with these models is in my opinion, the human factor, right? So it's not like we're just leaving the bay alone and looking at what affects what. We are a huge driver of the striped bass population, the crab population, all of the populations that we fish, and that's a really hard thing to tease out. Now, if we could somehow make a system where we could just say, all right, we're gonna take this area and no one can fish there, and somehow maybe we'll build a wall, make sure no one can fish and make sure no one can leave. We would actually be able to see those connections clearly. That's really hard.
I know.
And you have the other forces such as the menhaden fishery and how we go after them. And then you have the natural, talking about predators, the natural events that occur. What year was it that the red drum catch was so huge? Was that 2 years ago? 3 years ago now.
Something like that.
Yeah, maybe in
It's fairly-
2012
it's fairly
too, the year with
recently.
the huge Judy spike.
Yes.
We had an incredible red drum run at the mouth of the bay. The mouth of the bay were the very larvae we were just talking about. So it was the perfect storm, and many of them never reached maturity just because you kept your red drum, you didn't have to cut it open, it was just coughing them up. So all of that is just so complicated to grasp.
Yeah, very hard to tease out. That's where that fancy math comes in.
That picture you sent around of the 10-inch crab, I would think that had relatively few predators at that size, and we've heard that the average size of an adult is decreasing. Does that mean that it's on a death spiral as the adult crabs get smaller? There are more predators for the smaller crabs and so forth?
That is an interesting question. Well, I would say for those big crabs, I don't know what the Chesapeake Bay was like 3,000 years ago. We had sturgeon everywhere. We had like all sorts of things that were much bigger. The relic oysters the biggest relic oyster I have ever seen, this big. And that's not like a Debbie, that's like an old oyster this big, not long, so not a coon oyster, and this wide. We have that shell back at VIMS. So things back then were bigger. And they say in the paper, the one with the crab, that they think that the Native Americans probably only took 1% of the crabs from the bay. 1%. That's not much. We think that we're taking somewhere between 30 and 50% depending on the year. That's a lot more. So, one of the ways that management does things, and I'm not on the management end, I can't speak to that, but one of the methods is to actually have a size at which you can't take a fish or a crab to keep the large ones around. I don't know if that has been enacted, but I know it has in other fisheries. because the large ones tend to produce more eggs or tend to produce more sperm.